Now I'm going to create the block body. So for that I'm going to create that as a sheet metal component so that I can directly use the drawing what I obtained from it, the flattened image, and make it using cardboard. So for that what I'm going to do is I'm going to file new, and I'm going to select sheet metal, and I'm going to give the name as block body. So here the first thing I'm going to draw is the outline what I have already, the block dial dimensions what I had. So that itself will be the dimensions of the front side of the body. So that will be 270 by 100. So I'm going to take a rectangle from center. This will be 100. This will be 270. So once that is done, I'll use the tab command, click this, and yeah, it has a thickness of 1 mm, that's fine. We'll hit OK. Now I need a 15 mm fillet on both ends, so let me get that. Or I'll do one thing, I'm not able to find the fillet, so I'll just add it here itself. That should do the job. So other than that, the other thing I missed is the hole in the center. So that should be for 6 millimeters. We have taken 6 millimeters initially, so we'll keep the same dimension here as well. This, as I said, is a bit over 5.5 to 5.6 millimeters, which is the dimension of the hole that we need to punch in the middle. Okay, so that won't appear in the tab, so I think I should make some kind of a cut here. So I'll take normal cutout, and I'll select that curve if that is possible. And we'll select this body. Okay. Okay, anyway, I'll just add a cutout again. Not that much experience for the sheet metal work in next. So this should be for 6 millimeters. I'll take normal cutout. I think now we have a proper cutout. So after this, I need a base extending from the bottom. I need supports on either ends. So for that, what I'm going to do is I'm just going to take the flange, select this edge, and the bend radius I'll try to keep it as small as I can, so probably 0.5, because in the cardboard we are going to fold it. We don't really have a bend as such like in sheet metal work. And the length I'm going to keep it as 100 mm, which I feel is substantially okay, and I'll hit OK. And I'd like to create supports from either ends, so I'll take flange again and select this edge. And this edge I'm going to give the same 100 mm dimension, and from this edge as well. And once we're done with that, I'm going to create a taper here on either end. So for that, I think there's an option for a taper here. Yeah, chamfer. Click this, and instead of going for symmetric, I'll go for asymmetric. And this distance, I want this to be So I just want from the bottom edge, I'm thinking of having some 150 mm dimension here. So that should give me about, let's say, 120 mm, and backwards that will be say 80 mm. That I think is a proper taper. Probably I'll increase this 120 to say 150. This is the kind of the taper that I wanted. And I'll repeat the same thing on the other end as well. And this has to be swapped, so it will be 150, this will be 80. And we have a tapered end. Now, the one more thing that I want to create here is two flaps here and here, so that I can stick it onto the base. So I'll just select this edge, and I'll keep say just 1 centimeter. 50 mm, and apply. I'll do the same thing here for 15 mm. Hit OK. So this should be our base. I'll just save it, and I'll also flatten this along this face. Hit OK. That will be our flat pattern. So once we go into the drafting interface, we'll be able to have a flat pattern which we can use for our purposes. So we have the clock body itself ready. We can just have the whole thing flattened like this, and that can be folded at 3 edges and then glued down here. We can attach the movement from the rear end, and we can attach the dial face here, and we can attach the hand. So we'll just create a small assembly and try and see if it works fine. Now, just to check and make sure everything is working as we want it to be, we can we can make an assembly here, and we can check if everything works. So I have all the parts open here. I have the hand, the clock body, and the dial. So I'll go to File, New, and I'll select Assembly, and I'm going to give it a name, and I'll hit OK. And here the base part is the clock body, so I'll click that, hit OK, I'll select Fix, and I'll select this body and hit OK. Once that is done, in the application I change the interface to modeling. That's what I'm not familiar with, and I'll hit Add, and then I'll take the dial, I'll hit OK, and I want the touch align in first center axis. I'm going to create a center axis alignment between this circular face and this face. Hit OK, and now I'll go to assembly constraints again, and I'm going to touch align this face and this face. Okay, so that alignment is perfect. So after that, the next thing I'm going to add is the hand. So I'll click on hand, and I'll select, okay, I'll hit OK, and then touch align. I'll select this circle, I'll select one of these faces, click OK, and I'll go to assembly constraints again. I'll pull it to the front, and I'm going to give some distance between this face and this face. Anyway, in once we make the clock, this will attach directly onto the movement. So here, just for the purpose of our mock assembly, I'm going to give some value here. Hit OK, and then I'll go to View, Show Height, and then I'll hide all the assembly constraints and this axis by hitting W. Now, the next step involves a bit of trial and error again. First, I'll align the view so that the front face is visible. Yeah, so this is perfect. And I'll go to assembly constraints, touch align, and I'll try to move this and I'll try to align it exactly to the 1 o'clock position like that. Okay, so that is almost exactly covering the 1 o'clock position. I'll hit OK, and after that what I'm going to do is I'm going to open the dial and the hand individually. I'm going to open the dial, and here I'll go to view, and then I'll make sure that the coordinate system is on, so that the coordinate system is shown. In the R hand I'll do the same thing. I'll make sure that the coordinate system is visible, and I'll come back to the assembly. Here I'll right click on the dial and then replace reference set entire part. R hand, right click, replace reference set entire part. And now I'm going to create angular assembly constraint between this particular plane, and that is from the R hand, and this plane from the dial. Sorry, that was not supposed to be touch align. So I'll go to angle, and I'll select this plane, and the plane is not visible. Okay, the bottom plane is not visible here for some reason, so I don't understand why. Yeah, it is visible now, I think. So I'll take angle, I'll select this plane, and I'll select this plane. And now we already have one particular angular value here. I'll hit OK for the time being, and I'll go to view, and then I'll hide everything except the geometry, except the solid bodies. Now what I'm going to do is I'm going to go to that constraint what we just created, and I'm just going to fine tune it till this thing aligns with the 1 o'clock position. Oh, okay, I think I've created a wrong constraint. So I don't think I created the proper one. Okay, so for some reason this rotation is not locked. So first let me lock that rotation. So I'll select these two phases and apply. I'll hide this constraint. And now I think it will be easier for me to work with this. So I'll take angle again, and I'll select this phase and this phase. Let me first check if those are the right ones. Yeah, I'll hit OK. Now again I'm going to hide everything except the solid bodies, and I'll go to a proper view, and then I'll open the angular constraint what I've just created. Yeah, at around 12 degrees we see that we have a very good alignment with the 1 o'clock position. I think that's at around 15 degrees, that's a very good alignment. So from this point what I'm going to do is I can see that for clockwise rotation I have to increase the value. So I'll keep adding 30 degrees. So 15 plus 30, that will give me 45 degrees, and that aligns almost perfectly with the 2 o'clock position. And if I add 30 degrees again, I'm getting 75 degrees. That almost perfectly aligns with the 3 o'clock position. The next will be 105 degrees, that is with 4 o'clock position, 135, 5 o'clock position, 165, 6 o'clock position, 195, we can see on the bottom it's in the 7 o'clock position, and 225, 8 o'clock position, 255, 9 o'clock position, 285 10 o'clock position, 315 that is in the 11 o'clock position, 345 will be in the 12 o'clock position. So that's almost perfect. So with that, I think we can say fairly that the whole design what we have made is working perfectly. So we also have the indices in between in here on which we will just have a normal minutes and a seconds hand running continuously, much like a normal clock. But the hour hand is the Fibonacci spiral what we have created that is going to intercept the dial at these particular positions and shows the time. So with this complete, the next step is to create the drafts using these particular CAD models. Now I'm back with the clock body part and we'll create the drafts using this. So the first thing what I'm going to do is to go to the application tab, click on drafting. So in drafting, I'm going to select the sheet size as A2 because this whole thing is going to be very big, and I'll hit OK. Now I'm not sure if it is easy to get an A2 size printout, so I'll be putting a version of this drawing with the dimensions as well. So if you get cardboard, you can just sketch it on there and cut it to that shape. And I'll click on next. I'll leave everything as it is and click on flat pattern and then finish. And once I do that, I'll just double click on this, and in general I'm going to select the scale as 1:1, hit apply. So yeah, we have 1:1 scale, and I'm going to delete all these things. This is the instruction as to where to bend. That is good for the sheet metal work, but since we are doing it with a cardboard, we don't necessarily need it. And here we can see some overlapping, so while cutting we have to be a bit careful, and we have to hide this edge. So here I'm going to switch off the border display, and I'll see if I can create a line here which will indicate as to where we can cut. Okay, so I'm not getting the exact point here. That will make it a bit difficult. So I think I can leave it as it is, and then when we are making it, when we are actually cutting it, we can probably be a bit careful and cut it better here. So I'll create the dimensions here, so that I'll keep two versions, one with the dimensions and one without, so that for someone where A2 prints is not available, so probably even I will not be able to get in A2 printout, so we can probably just use the dimensions itself and make this. There will be few decimal point differences here due to the fact that we have given some bend radius. So you don't need to be that precise while cutting. If you can get a printout, that's probably much better. Take the dimension from the middle line. I think that's yeah, we'll have to add the overall width. I think I'll add it from edge to edge. It's better to have 100 mm from because we have designed the dial for 100 mm, and the length itself from here till the top. Okay, that is supposed to be 270. So yeah, 269 is fine. And I have a hole exactly in the middle. I'll just add a note here. Some kind of an issue with the X, I think. So here I'll just add a text saying that cross 250 with 6 mm dia hole in middle. I'll put that text here, so I think I'll just that is the basic thing what we want. This is the thing we have to cut and make as the clock body. So I'll just save this, finish sketch. Once that is saved, that will be our the clock body. Now we have to make the clock dial and the hand. Now let's create the draft of the dial and the hand. So for the dial, I have the dial file open. I'll go to application, drafting, and then now standard size A4, hit OK, and I'll select next, make sure the view which is showing the face is selected, next, and hit finish. So here I'll double click on it, under general, going for 1:1, apply, and we see that there's a lot of clipping here, so I'll go to angle and I'll rotate it by 90 degrees, so it is going to fit in the A4 size sheet. And that's it. We'll just have to add color into this, and we'll come to that. I'll probably hide this, yeah. So also I'll again go to view, tools, yeah, preferences, drafting, and hide the display of border, so that we'll have this dial. I'll save this and I'll go for the hand, and in the same way, first I'll just hide the center line, go to application, drafting, standard size A4, okay, and then the proper view is selected, next, and finish. And again I'll go to preferences, I'll switch off the border, and I'll hide the cross on the center line as well. So the only thing that is remaining is to add color into this and then save these files into a printable format. So we'll come to that. Now as I was going through the drafts which I had created, I noticed a couple of issues and I felt I should correct it before I go any further. So let me do that here, mainly in the dial. The advantage of using a software like NX or SolidWorks is that once we update the CAD model, usually the draft file gets updated automatically. So let me open the dial. Here the thing is that the text what I have used here, US, it's very thin in the draft. It's coming out to be very thin. So I felt that I should increase that, the width of it. So let me click on this, and I think I'll go for 10. Yeah. So I feel that's better. And the other thing that I wanted to do here is that I just wanted to add the text Fibonacci clock right here. So Fibonacci clock, I just don't want to commit a spelling mistake, so I'll just add the text Fibonacci clock in here. And for that, first thing I need to do is to draw a sketch. just use this as my reference sketch, and I'll add the text. Fibonacci clock, and I'll select this as the face and this as the reference curve. Yeah, I think that's good. I'll see if I can write it in 2 lines, or I'll reduce the height to 6, maybe on 4. Yeah, and alignment is at center. Yeah, I think that's about it. So let me just see if it looks good enough. And one thing is, try to attach it to the midpoint. Yeah, right there. Okay, so once that is done, let me just cut this as well. I'll hide the sketch, and using the text what I've created, let me just create a cut. That's it, and I'll hide the text as well. And once we go into the assembly, we'll see that once I double click on assembly, everything is updated here already. And the other thing that I need to check here is that I'll just go to one of the views where I can see the front face properly, and I'll just hold the hand and make sure it doesn't touch the ground, so that we don't have any kind of an interference in the operation. So thankfully it doesn't. If it does, then probably the curve will have to be trimmed accordingly. So once that is done, I'll hit OK, and I think we can proceed with the rest of the draft. So the next step in the drafting is to assign colors to the dial. So I have already decided the colors. Since I'm a bit weak in colors, I've taken my father's help, and I have decided on some of the colors. So I'll go to drafting, and let me just update everything first. Yeah, now it's updated. And with that, what I'm going to do is, I have decided 3 different colors, one for the background, one for the lines and the indices, and the other for the text. So I have 3 colors, and also for the R hand, we'll just color it black. So for this, what I'm going to do is, I'm going to use this area fill command. So before doing that, I'll right click on drawing and unselect monochrome, and we have this kind of a colored background. So if we have monochrome selected, then none of the colors will be visible. And I'll select this area fill, and I'll make sure that this pattern is selected to solid fill. I'll specify the boundary. So for the background, what I'm going to do is, I'm going to select this whole area. It will take a bit of a time, but it will select most of the area which I want to fill. But whatever is in between, I'll have to select that separately in between the text. So here we can see that this circle is not selected. Inside the 4 we have this triangle. Inside 10, 9 and 8 we have areas, and even here we have few areas. I'll select all that, and once all that is selected, I'll go to color, and the color I want to fill it with is this this particular one, which is ash gray, and I'll hit OK, and I'll hit OK again, and it will take some time to fill. Now that the gray color is filled, we can go ahead and fill the other colors. Now here I went ahead and I just increased the width a little bit more to 15 millimeters, and now I'm going to fill the rest of the things here. So the first thing that I'm going to do is I'm just going to hatch this part, so that it gives a clear indication that these parts need to be cut for the moment. I'll just give a value of 1 mm there, I think. Yeah, that's fine. And I'll just take the fill again, and I'll first select all the indices, so these curves as well as the indices for the minutes hand. And on this end as well. once you are sure that everything is selected, just go over everything and make sure everything you want is selected. After that we can pick the color, and for this one the color that I'm going to use is number 212, which will be deep blue. I'll hit OK. It will take some time to fill everything. After that let's go ahead and fill all the texts in. So the same procedure again. I'm going to select everything that I want. And maybe I'm going to make this in black, so I'll just select the rest of it, and once everything is selected I'll go ahead and select the color that I want, which is 186. That should be red, I think. Terrible with colors, that's the reason I've noted it down before. So you can choose the colors that you like. Once we hit OK, it's going to take some more time, and after that, yeah, everything's filled. Okay, I think there's a mistake. 212 is deep blue. Yeah, it's supposed to be 186. I'm sorry. Yeah, so it's supposed to be 186, not 212. Yeah, so that is all in red now. And I just had a change of mind. I think I'm going to make this Fibonacci clock in black. Initially I thought I'll be making that in red as well, so I'll just select all the text here. Once everything is selected, I'm just going to go for either the black itself, or yeah, I think I'll go with the charcoal gray. I'll hit OK. Yeah, I think that should do, and I'll hit save. Now the other thing that we need to color is the R hand. So for that I'm just going to open the R's hand. This is much more simple, much more straightforward, so I just need it only in black. But anyway, I'm just going to get rid of that monochrome selection, and I'll take the fill command. Since I've used black last time, it's still selected. I'm just going to select the area that I need to fill, and I'll hit OK. And with that we have a black R's hand. No, I think we had selected charcoal gray, so let me just make it black completely, and I'll hit OK. Yeah, so that does our R's hand. So after this, we'll have to save this into printable files. Now the next thing that I have to do is to save this in a format in which I can print it. So one way is to save it as an image. So usually we have the options to export it as images, but I have not had the best of the results trying to save drafts as images here. So what I'm going to do is I'm going to file, export, and select PDF. And once this dialog comes up, I'm going to keep the image resolution as high, and in here I'm going to point it towards another folder where I'm going to call it as the dial. And make sure everything is as you want, make sure the size is in full scale, and I'll hit OK. Now, if you remember, when we gave the sheet size, we have given it as an A4 size sheet. So now the PDF will also be in the same size. Now we can see that the PDF looks much different. The colors look much different than how it does in the software. So due to the sharpness, I think the text is not coming out very neat. So if the print itself doesn't come out properly, I'll probably go ahead and alter this. The rest of them is fine. And only this text I have a bit of a concern. So I'll probably take it as print and check it once. And also the other thing that I have to make sure is that the dimensions have come out accurately. Now we are using a CAD software, it will be accurate, but just for the safety, I'm going to use an online utility, an online this website where I can just drag and drop my PDF file, and I can take one of these scales and make sure it's set to mm, and I can just drag along the width, and we want it to be around 270 mm. Yeah, it is. And the width, it's not precise what I'm doing, but just to get an estimate if it's right, so it's about 100 mm. So when we're taking a printout, we should make sure that these dimensions are maintained. So probably we can have a scale and make sure it's maintained. So in the same way, I'm going to save the hours hand as well. So we have the hour hand, and we'll just go to file, export, PDF, and in the same location I'm going to call it as the hour hand. Make sure image resolution is at high and the rest of things are fine, and I'll hit OK. Yeah, so the PDF is exported, and let me just check it, and that's fine. And other than this, we also had the other thing, which is how the box is to be built, the kind of the support for the clock body. So even this, I can save this as a PDF, so I can take a printout of this and use that as a reference. I'll be taking a few more diagrams with proper dimensions. So one is this, to make the clock body, so that we can just use these dimensions and build it. The other thing is the overall some of the dimensions of these parts itself, so that once you take the printout, you can have a kind of a reference with which you can just verify if the printout has come out to the right dimension, because the dimension is everything here. Because it's a Fibonacci clock. If it's a normal clock, probably if it's off, it will still work, but here it won't. So the dimensions has to be precise. For that reason, I'll be including that as well. And once I get all the PDFs, I'm just going to combine them into a single PDF, and then I'll show that. Now all the drawings are ready, and they're merged into a single PDF of 4 pages. And here we have the dial itself. And the thing is, I'm still not sure if this is going to come well in the print, the Fibonacci clock, what I put here. So maybe I'll have to modify that, because only if I zoom it and it's showing up well. So I may end up modifying that once I take it as print. I have the hour hand here in the second page. I have the dimensions, all the dimensions required to cut out the clock body here in the third page. And I have reference dimensions for the dial and the hand in the fourth page. So this is to make sure that once you take the print, you have a reference to match it against, to make sure that you have got the right dimensions in the print, because as I said, the size is very important, dimensions are very important in the Fibonacci clock. So for that reason, I have included this in the fourth page. So I'll be uploading this PDF, and this you can directly use it to take a printout. You can probably modify it, you can use the drawings what I have done and modify it, or you can make it yourself. So this is for people who wants to directly just build the clock and not worry about designing it. If you don't want to use, probably you can use some software to convert this into an image and just block it off with the background color, since it's a solid color. So this is about it, and the next step would be to build the clock. Now the PDF is completely ready. I have the dial, the hours hand, as well as all the other drawings ready here. So first, in the first sheet, we have the dial, and this is in the the landscape configuration here. And you can take a printout of it. Make sure that when you take a printout, there is no scaling. And in the second page, we have the hour hand, and in the third page, we have the diagram, the dimensions for making the clock body. And in the fourth page, we have the dimensions of the hour hand and the dial. So this is to make sure once you take the print out, there is no scaling. And for that reason, what I'm doing is I'm first taking a rough print, and after that I'm printing it on a photo sheet. So that's the approach that I'm taking. And here, if you want any alterations, you can do it with this image, or you can print it as it is as well.